Hello, good day. My name is Christina and my topic is entitled Odor Dispersion Distance Modeling of Fattening Pig Farm using Computational Fluid Dynamics. Among all the livestock in South Korea, swine industry is known to be the largest in terms of the production volume, contributing to about 45.7% of the total livestock annually. With the increase in demand due to population growth, the volume of production was increased to more than 40% from 2005 to 2019. However, the number of pig farms constantly decreases, reaching only more than 6,000 farmhouses during this year's second quarter. This production upsize leads to the increase in manure generation, where more than half of this manure is from pig facilities. The intensification in manure generation resulted in large number of complaints concerning foul odor. With this, efforts has been made to quantify the amount of odor dispersed near the livestock house. The general aim of this study is to develop three-dimensional model with complex topographical conditions used to predict livestock odor dispersion using computational fluid dynamics. Initially, the research was divided into two categories. First is the field experiment and second is the CFD model generation. A field experiment was conducted to select the target experimental area to gather data and information about the meteorological condition. CFD model generation, on the other hand, is the creation of the three-dimensional experimental model. To provide a reliable simulation results, a model validation was also made, and finally, simulation of case studies were done. After the success validation, simulation of odor dispersion considering various environmental conditions was also conducted. The target experimental area was located at Buwon-gon, Chungcheongbuk-do, South Korea. The farm is composed of 3 pig houses with 850 heads per pig house. Both the internal and external environment, such as the temperature, humidity, wind speed, and odor concentration, were measured following the international standards procedures. In case of odor concentration, a dynamic field olfactometry was conducted for each field experiment. The next step is to design the domain with complex topographical conditions. This was done by utilizing various software such as ArcGIS, AutoCAD, SketchUp, Rhino, Design Modular, and Fluent. Considering that the domain size is very big and the topographical condition greatly affected the vertical wind, a log wind profile was used. A log wind profile is commonly used to describe the vertical distribution wind speed within the lowest portion of the boundary layer. A validation was also conducted to test the accuracy of the CFD simulated results. This includes grid-independent tests, time-step tests, and turbulence model tests. The results of the CFD model with selected turbulence model and grid size is compared with field-measured data. After successful validation, set of cases to simulate odor dispersion considering various environmental conditions were made. The table in the right bottom corner of the poster showed the simulation results of livestock odor dispersion around experimental farms under different conditions. A total of 4 variables, including the ventilation type, wind speed, atmospheric stability, and wind direction, were considered. The simulation results showed that the odor dispersion length ranged from 78.9 meter to 1,488.1 meter. The lowest wind speed, stable atmospheric condition, and use of side exhaust fan will result to longest dispersion distance. To conclude, CFD can accurately represent topographical condition of the target experimental domain. For the future study, the simulation can be improved and be integrated with the web-based forecasting system for odor monitoring.